Welcome back, Science 9. Today we are going to get our chapter 1.1.4 started of Unit D. Before we go through, I'd like to go over some homework questions, which are our science log activities, and we're going to do first half or 1/3 of Unit D, chapter 1.4. So the first question is asking about the safety. Determine what is more dangerous, current versus voltage. In the end, both are dangerous. If I tell you the conclusion first, however, if I put an emphasis, if I bother go through which one is more dangerous, current is more dangerous because current is a direct measure of how much electrons pass through a matter. So analogy-wise, this is kind of similar as a flow rate. High current generally create high voltage too. However, current tells you how much damage that you can do to any living organism. Compared to the voltage, voltage is more like a pressure difference. In water, if you think about that, like a dam with the more water, more height versus a dam with less water or not much of height, something like that. Yes, if you have a lot of pressure, you will have more current. So technically voltage causes current. But again, current is the one that damages more. The second questions talk about what is the purpose of electric fuse. First of all, if I draw the fuse, in a cylindrical structure, we have a metal strip that goes like that. Fuse basically prevent overheat in a circuit system by melting a metal strip. Some answer along this line is acceptable. And if you wonder why that, let me choose a different color. If you wonder why that is a safety device, it's because once the metal strip is gone, broken because it's melted or something like that, the circuit is incomplete. That's a fancy way of saying electricity will not gonna flow. Next question is asking you to describe or explain what is a short circuit. I like to say short circuit is unintended. Most of the time, if it's safety related accidental circuit created by alternative paths. Actually, let's unalternative path. Most of the time you have one path. Okay, so let's think about good old example of electric wire. Let's not forget transformer. Let's say we have a power line that cut off from one end to another end. So this area over here, obviously, we are experiencing some kind of incomplete circuit. But imagine there is a person over here. Then, now let's think about electricity's perspective. Electron, which used to have no way of going through, now can go through human body and then go to the grounding. This is an example of short circuit. By going through that power line area, you just created a small completed path that where electron can go through. And this is where electric shock will happen. I cannot write today. There you go. This question is an important one. A power line carrying a high current falls on a car, but the people inside are not oops. There you go. The people inside are not electrocuted, aka safe. Why that happened? I'll rather draw a picture to describe the whole situation again if you don't mind. Transformers. Most of the time you don't have transformer that close together, but in any case, one of the end, the another end is connected. And let's say we have a vehicle. Oops. Yeah, good idea to actually wait for my drawing, then you can copy. Imagine there's a car. There you go. To be fair, it doesn't matter whether, actually this line, let's make it more realistic. It's just droopy. Let's say this is a situation. First of all, the vehicle, what I'm using, whatever that I'm writing in green represent the vehicle's perspective. Whatever I'm writing in red will be human perspective. Now, vehicle creates a short circuit. That's a fancy way of saying, if you think about electron movement, go down through the damaged wire, and you notice vehicle are a good conductor. They're metals. So it's gonna go down, then connects to the grounding, which is a fancy way of saying electron will go towards the earth or inside of the earth. Now, if you think about this perspective, it's quite safe because human inside I don't know. I'll draw a couple. Human inside, they are encapsulated by the metal conductor, which is the plates of vehicle and so on. Inside of this scenario is safe because you are shielded. And fortunately, the metal that I'm highlighting over here are the ones that become a part of a circuit, not your body. But as soon as you go outside, then you are making a new circuit. Thus, you will be in trouble. Electric shock. Oh, I just realized science log activity 11 kind of overlap. It's exact same as 10, so I'm gonna skip this part. All right, this question's talking about the tall building in interaction with lightning and how lightning is actually attracted, strike if you will, to this rod during the storm, why these rods are added, and how do they work. Also, it talk about ground with wire. So let's talk about this again using the drawing if you don't mind. So let's say we have really tall building and we have a lightning rod. If I magnify this lightning rod, it is pointy at the end. Last class I mentioned in my class that if you think about this tip, sharp tip, this is an area where I have less surface area, right? Pointy end means you don't have a lot of surface. That's why it is pointy. Just because of that simple fact. If it has a lot of surface, then it's gonna be like a cylinder lid, those kind of thing. Now, one thing that I want to point out to you is if you have a less surface area, now let's magnify this a little bit more bigger scale. Now it's unrealistic. Actually, I'm gonna make it a little bit more realistic. There you go. And let's draw angry dark cloud over here. If you guys remember about lightning phenomena, there is a charge separation occur inside of a cloud. Because, first of all, static electricity is a phenomena that make different polarity happening due to the water molecule that rub each other and then undergoing high friction inside of the clouds, or small clouds become bigger clouds, those kind of thing. Which is one of the reasons why when it comes to storm situation, you see a big clump of cloud that seems like one cloud that covers the whole sky, something like that. Now, let's think about the lightning rod over here. Even if you have positive charge and negative charge, imagine there is two different types of lightning rod. The thing is, I draw the same number. If you look at just the surface, can you see that pointy end is more concentrated area, which is a fancy way of saying more surface area means it's kind of diluted. You have way more other possible area that you can hit. On the other hand, when it comes to tip situation, only this core is the one that can possibly have positive charge, something like that. The thing about electricity is electrons and protons, they are attracted. You guys know that. The negative and positive, they love each other. The only thing is electron is the one that you can go towards, and they are very attracted by a concentrated area where it has a less surface area. This is the reason why lightning always strike the rod. Also, if I give you a little bit of a hint, I do not recommend you bring umbrella when it comes to storming situation, because umbrella have a little tip that go out too. If you're unlucky because of the small surface area, you can have a lightning happening towards that rod, something like that. So why are these rods added? Because this concentrated area will attract the lightning towards the lightning rod, which is quite safe when you think about the trees around. So let me draw trees around, or any of a human that walk back and forth. It's gonna hit lightning rod as priority. That's why. On the other hand, if the lightning rod is faulty, then probably second will be a taller tree than human, something like that. So when it comes to safety feature, lightning rod is a must item that people need to install in any building. This example is about judging a friend's action. A friend who removed the third prong of the plug. Is this a wise movement? I like to say absolutely not. Let's think about our plug. Or sometimes it's actually circle, something like that. If you think about these two, we must need it because one of them is positive end and another end is negative end. What was the purpose of the third prong? Third prong's purpose is grounding. It has a grounding wire, or I like to say, let electrons pass safely to Earth. Removing this is not a wise decision at all. That means without that usage, where you're gonna have your grounding, it's gonna ground to your body. So imagine your hand going there to connect it. Then the funny thing is, your body is the one that make a short circuit. An electron will go through your body and through your leg. It's gonna do grounding. So your body is your grounding path. We already spent a lot of time for going over the homework question, which is very significant. And let's go through a little bit easy lesson of chapter 1.4, cells and batteries. All right, let's go ahead with our one of the type of cell, which is what you guys are pretty much familiar with, the normal battery that you generally see. We call it dry cell. Why it's called dry cell is because, well, if you look at the picture on the right side, it's very straightforward. There's no solution. You are not having any wet solution inside of it. It actually is more about the paste. Like, think about glue, except it's metallic glue. Electricity producing cells that have chemicals in a paste. Paste is, think about it, more of a solid than the liquid, but it's still flowable. So think about larva and think about like syrup, if you will. They are sealed so the chemicals cannot leak out. Anything that you're using in electronic devices that require Duracell or rechargeable battery, AA, AAA, those kind of guys, most of the time AA and AAA, you guys are using for your toys and electronic devices like advanced calculator. Those are the ones that use chemical reaction inside of the dry cell. And we call this chemical reaction that release electron known as electrochemistry. You guys will learn about that in advanced high school chemistry courses. But if I elaborate it in grade 9 level, there's one end to another end, cathode negative, anode positive, something like that. Cathode area is any chemical reaction that gain electrons. Anode is anything that lose electron, which at this point you may think about that as a why it's negative because you gain electron, and then why that's positive because you lose electron, something like that. These rates are balanced. Every single phenomena that you see in chemistry, everything is balanced. So if I gain one electron, I should gain it from another chemical part of a reaction that lose one electron. It's 100% give and take. And there's no greediness happening. The one who discovered and invented dry cell is Alessandro Volta, which we discussed in the previous chapter, who found the potential difference. He invented the voltaic pile, which is the first electric battery that you can see from below over here. The thing about dry cell, ladies and gentlemen, a dry cell battery is, even though you don't know about batteries and cell, I like to say cell is a singular unit, battery is multiple of cell, so it's plural. The way that you can see down there is, can you see this single sandwich looking combination? Copper, zinc, and then there is a electrolyte in between. Yeah, imagine you're stacking that as a 1, 2, 1, 2, 3, 4, 5, 6. So it's a 6-decker sandwich. You can think it in that way. The whole thing, we call it battery. The one tiny part of repeating unit, we're going to call it cell. Even though you don't need to know about chemical reaction in detail, you should at least understand how that chemical reaction works as an overall generic way. You don't need to memorize this chemical reaction. Few things. Like I mentioned, in any battery, we have positive end and negative end. That is what I like to call a terminal, positive and negative. Now, one thing that you need to know is anode side lose electron. Cathode side gain electrons. You don't need to know which end is which. One thing that you need to know in grade 9 science is, can you see 2 electron, 2 electron? These electron exchange are balanced. That's literally the only thing that you should pay attention when it comes to grade 9. It's not a simple chemistry reaction. You need a reference table, data booklet, calculation. It's a complex part. So long story short, you just need to know a few things. Even though I put that as a dry cell, but in the end, every single cell does it. Electron travel from negative terminal to positive terminal. That's something that I want you to understand. We are not talking about our conventional one, like the one that you see over this picture over there. Even though I pick it because it showed a chemical reaction much, I'm not overly happy about the direction. If it's connected through the wire, negative end had excess electrons, so aka you have a lot of electron. So it goes like this. So how can we make a battery? Well, if I tell you we need 2 metals and 1 electrolyte, which has ions, any ions to be honest, even salt water, seawater can be a good example too. Not the best one, but you can still make the battery run. So a cell has to have 2 different metals. Why 2 different metals? Is because, for example, if I choose copper and copper, then electron will confuse which end is a positive, which end is a negative. So the good example that we generally do in the lab is copper and zinc, something like that. The electrolyte is also needed. It's a basically conductor that connect those 2 metals together. And electrolyte has to have some kind of ion. So the one that Alessandro Volta built was, we have copper. Imagine a sandwich. There was some kind of electrolyte. Imagine ham, egg, whatever you can think of. And we have another metal, zinc. Order of these 2 doesn't matter because we can flip anytime. But this whole thing is a 1 unit of cell. This is minimum required Two metal, different metal, and one electrolyte that's sandwiched between them. Dry cell, if you think about the mechanism, one lose electron like I mentioned, another side need to gain electron, and these two has to be balanced. If it's not balanced, electricity flow doesn't work. Rather overheat happen or reaction is not spontaneously happen. An ion is an atom or group of atoms that has become electrically charged through the loss or gain of electron to one another. We learn about that in chemistry unit quite a bit. For example, copper, solid, this is atom because you have neutral charge. That means it's neither positive or negative. But if you think about metals, metals tend to turning into positive charge. Copper, common charge is copper 2 positive, something like that. This is a fancy way of referring that I lost 2 electrons. That means we have more proton number than electron number. If you think about something like chlorine, chlorine is a liquid at the room temperature. Chlorine atom, non-metal, yes, it's neutral, but if it's involved with any type of electron exchange, chlorine tend to be Cl minus, and this minus actually refer how much you gain. In this case, gain 1 electrons. If you look at these two, copper and chlorine though, copper lost 2, chlorine gained 1. So back in chemistry unit, we used to put CuCl2 because that's the only way we can balance 2 positive, 1 negative, so we need 2 of them. Something like that. Even that time, we learn about how ionic compound can be made by adding or combining, if you will, positive charge metal and negative charge non-metal. It's very similar. Why do we need 2 metal? It's because one metal will be positive N and another metal will turning into negative N. Thus, positive and negative N. We call these two different metal end or terminals, if you will, as electrodes. One electrode becomes positively charged, another electrode becomes negatively charged in the process of gaining electron or losing electron. These electrodes are connected to the dry cell's terminal. So if I look at this picture situation here, can you see that it's a three-dimensional portion of a dry cell, like 9-volt battery, something like that? D cell, if you will. Graphite rod, in this case, is cathode. Zinc container at the bottom is anode. So if you really want to know the detail of the positive charge and negative charge, you can kind of memorize in this way. Cathode is positive, anode is negative. Even though, like I mentioned, this doesn't play any huge role in grade 9 science, but it will come out big time as soon as you go to high school. My tip that I generally put, if it's cathode, can you see this T is similar as positive? You can remember in that way. Cathode, always positive. That's it, ladies and gentlemen. We learned about dry cell today, and next class we're going to learn about wet cell. First of all, I want you to do the exercise after this video lesson, which is posted on the Google class near the end of this block. And no homework for today.